Populations, Chapter 1, Lesson 2. Births and deaths. The most common way in which new individuals join a population is by being born into it. If more individuals are born into a population than die in any period of time, a population can grow. So when the birth rate, the number of births per 1,000 individuals for a given time period, is greater than its death rate, the number of deaths per 1,000 individuals for a given time period, the population may increase. The main way that individuals leave a population is by dying. If the birth rate is the same as the death rate, then the population may stay the same. In situations where the death rate is higher than the birth rate, then the population may decrease. The population statement. When the birth rate in a population is greater than the death rate, the population will generally increase. This can be written as a mathematical statement using the is greater than sign. If birth rate is greater than death rate, population size increases. However, if the birth rate in a population is greater than the birth rate, the population size will generally decrease. This can also be written as a mathematical statement. If death rate is less than birth rate, population size decreases. Immigration and immigration. The size of a population can also change when individuals move into or out of the population. Immigration means moving into a population. Immigration means leaving a population. For instance, if food is scarce, some members of an antelope herd may wander off in search of better grassland. If they become permanently separated from the original herd, they will no longer be a part of that population. Graphing changes in population. Changes in a population size can be displayed on a line graph. The vertical axis identifies the number of animals in a population, while the horizontal axis shows time. The graph represents the size of the polar bear population over a certain time period. Population density. Sometimes an ecologist needs to know more than just the total size of a population. In many situations, it is helpful to know the population density, the number of individuals in an area of a specific size. Population density can be written as an equation. Population density is equal to the number of individuals divided by unit area. For example, suppose you counted 20 butterflies in a garden, measuring 10 square meters. The population density would be 20 butterflies per 10 square meters, or 2 butterflies per square meter. What factors limit population growth? When the living conditions in an area are good, a population will generally grow, but eventually some environmental factor will cause the population to stop growing. A limiting factor is an environmental factor that causes a population to stop growing or decrease in size. Some limiting factors for populations are weather conditions, space, food, and water. Climate. Changes in climate conditions such as temperature and the amount of rainfall can limit population growth. A cold spring season can kill the young of many species of organisms, including birds and mammals. Unusual events like floods, hurricanes, and tornadoes can also have a long-lasting effect on population size. Space. Space is another limiting factor for populations. Gannets are seabirds that are usually seen flying over the ocean. They come to land only to nest on rocky shores, but the nesting shores get very crowded. If a pair does not find room to nest, they will not be able to add any offspring to the gannet population. So the nesting space on the shore is a limiting factor for gannets. If there were more nesting space, more gannets would be able to nest. The population could increase. The amount of space in which a plant grows determines whether the plant can obtain the sunlight, water, and soil nutrients it needs. For example, many pine seedlings sprout each year in forests, but as the seedlings grow, the roots of those that are too close together run out of space. Branches from other trees may block the sunlight the seedlings need. Some of the seedlings then die, limiting the size of the pine population. Food and water. Organisms require food and water to survive. When food and water are in limited supply, they can be limiting factors. Suppose a giraffe must eat 10 kilograms of leaves each day to survive. The trees in an area can provide 100 kilograms of leaves a day while remaining healthy. 5 giraffes could live easily in this area because they would need just 50 kilograms of food a day, but 15 giraffes would not all survive. There would not be enough food. No matter how much shelter, water, and other resources there were, the population would not grow much larger than 10 giraffes. The largest population that an area can support is called its carrying capacity. The carrying capacity of the giraffe habitat would be 10 giraffes. The size of a population can vary, but usually stays near its carrying capacity because of the limiting factors in its habitat.